everyone, welcome to EduVriddhi. In the present video, we are going to study problems on distance, height and directions. These type of problems appear in general aptitude section of CSIR net exams and also in some other competitive exams. And while dealing with these type of problems, there is a great need to have theoretical background and also knowledge of some related formulas. So before solving the problem, let us see some points and formulas that should be taken into note. So these problems on distance, height and directions can be categorized into two. One is problems related on only distance and directions, and another one problems on distance, directions and heights. So whenever we speak about direction, there may be two cases. In one case, there may be one object whose directions are specified by using north, south, east and west directions, or sometimes it may be specified by using left and right. So that is the first case. So if you consider one example, in this case, this object is moving from south to north, or I can tell that the object has moved towards north. So this is the first case where there is a single object and we specify its direction or its movement by north, east, west or south, or sometimes it may be towards left or right. And in the second case, there may be two objects out of which the direction of one object is specified with the direction of other. So here there are two objects, object 1 and object 2. So here I can tell object 1 is moving towards object 2. So this is the second case of specifying the direction. Next, let us see points and formulas to be remembered while dealing with any of these kind of problems on distance, height and directions. So there is one case. In this case, there is an object and this object may be a person, animal or anything, and this object or person is facing towards north. This person is facing towards north, and I'll represent that one as N. And we know that we will represent direction in this way. This is north, this will be east, this is south and this is west. So this is a person who is facing north direction, and now he is told to turn right. Okay, turning right or turning implies 90-degree rotation. One turn is equal to 90-degree rotation, and turning right implies that if this is the person who is facing north, at first he will be facing north. Now he will rotate through 90-degree in the clockwise direction. Turning right implies clockwise rotation through 90-degree. So he will rotate in clockwise direction, and finally if you see, the face of the person will be towards east direction. So that is our conclusion. If he turns right and rotates through clockwise direction, finally his face will be towards east. This is the point to be remembered. Whenever a person or any object faces particular direction, and if it is told to turn right, it will turn through clockwise direction through 90-degree, so that finally the face will be towards some other direction. And there is another case. In this case, the face of person is towards north as the earlier case, but in the second case he is told to turn left. Okay, this is the case. When he is told to turn left, that is nothing but rotating through 90-degree in the anti-clockwise direction. So if you take the directions as it is, this is north, south, east and west. Now the person is here, he is facing towards north direction. Now since he has to turn to left, he will turn through 90-degree towards left. So finally his face will be towards west direction. This is our conclusion. So he will be facing towards west direction. This is the second case. So totally we can conclude that whenever an object faces a particular direction, if it is told to turn right, it should rotate through 90 degree in the clockwise direction, so that finally face will be towards some other direction. And whenever an object is told to turn left, it will rotate through 90 degree in the anti-clockwise direction, and finally the face of that object will be towards some other direction. Next, let us study Pythagoras theorem. This is one of the important theorem which is helpful to solve the problems on distance, height and directions. So this theorem is applicable wherever there is right angle triangle. So we know that to solve the problems, we take data from the question and draw some figures or pictures. Okay, if the images or pictures which are got by that problem contains right angle triangle, then in that case we can apply Pythagoras theorem. So this theorem is applicable to solve these problems. And according to Pythagoras theorem, if there is a right angle triangle is a triangle which is having one angle equal to 90 degrees. So this is the right angle, and the side which is opposite to that right angle or 90 degree angle, it is called as hypotenuse, and this is called as height, and this horizontal, it is called as base. And according to Pythagoras theorem, we have a formula: hypotenuse square is equal to height square plus base square. This is useful for solving problems. So if you have any of the two datas, maybe height and base, then you can calculate hypotenuse. If you have hypotenuse and height value, you can calculate the base. So this is very important in solving these problems. Next, we have to study about trigonometric ratios. So once again, if you consider any right angle triangle, the side which is opposite to that right angle, it is called as hypotenuse, and there will be another angle, and this is the angle to be found out, and the side which is opposite to that angle, it is called as opposite side, and the horizontal is called as adjacent side. And according to the formula of trigonometric ratios, we have sin theta is equal to opposite side by hypotenuse, and cos theta is equal to adjacent side by hypotenuse, and tan theta, this is the ratio of sin theta and cos theta, so it will be equal to opposite side by adjacent side. And cosec theta is equal to 1 by sin theta, that is, it is the inverse of sin theta. So if you see here, you can understand cosec theta is the inverse of sin theta. So cosec theta will be equals to hypotenuse by opposite side. So that is given here. And secant theta, it is the inverse of cos theta, or it is equal to 1 by cos theta. So you can tell that secant theta is equal to hypotenuse by adjacent. So that is given here. And finally cot theta is the reverse or inverse of tan theta, and we have tan theta is equal to opposite by adjacent side. So cot theta will be reverse of that. So cot theta will be equal to adjacent side by opposite side. So these formulas are to be remembered by us while solving these problems. And if one knows the formula of sin theta and cos theta, other formulas can be found out. Next, we have to study trigonometric ratios of some specific angles, especially 0 degree, 30 degree, 45 degree, 60 degree and 90 degree. On the left side, we have here different trigonometric ratios, and here there are corresponding angles. And if you study this table, you can easily use this in the problems. And we have here sin theta, that is, here theta is 0, sin 0 is 0, sin 30 equals to 1 by 2, sin 45 1 by root 2, sin 60 root 3 by 2, sin 90 is equal to 1. And cos 0 is equal to 1, cos 30 is equal to root 3 by 2, cos 45 is equal to 1 by root 2, and cos 60 is equal to 1 by 2, and cos 90 is equal to 0. So if you see here, you can understand this cos theta values are reverse of the sin theta values. And tan theta, we know that tan theta is equal to sin theta divided by cos theta. So if we don't know these values, we can just divide sin theta by cos theta. These values can be divided by these values, so that finally we will get the values of tan theta. And tan 0 is equal to 0, and tan 30 is 1 by root 3, tan 45 is equal to 1, tan 60 degree equals to root 3, and tan 90 degree is 1 divided by 0, so it is not defined. And finally we have cosec theta, which is the inverse of the sine theta. So if you take the inverse values of these values, you will get these values. And similarly, we have values for secant theta, which is the inverse of the cos theta. And finally, we have cot theta, which is the inverse of tan theta. So you have to at least know the values of sine and cos functions, so that finally you can calculate the other trigonometric ratios. Next, we have another important formula, that is corresponding to degree and radian measure. So remember, 1 degree, that's equal to pi by 180 radian. Always 1 degree will be equal to pi by 180 radian, and 360 degree, that will be equal to 2 pi radian. This formula is useful in solving problems. So this is about theory and formulas related to distance, height and direction problems. In the next video, we will try to solve some problems on this aspect. Thank you.